Hey guys, in this video we are going to attempt to make some combat using AI in the Unreal Engine. I'm going to start up by working with the third person template. Here we've got a third person character, and our player actually starts as a third person character. Characters are subclasses of the pawn class, and a pawn is basically like an avatar that can move around the game world. Um, we can drop in other characters and we can use them, as NPCs. Even though this one, has a camera built into it. Um, let's see what happens here if we play. So one of them is possessed by what we call a player controller, and the other one isn't possessed by anything. It's just standing there. So what we could do is we could possess that other object with an AI controller, and then give it some logic so that it can move around. So in order for us to give it any logic, we have to create something called a behavior tree. And if we right click, let's create a folder for our AI. And in this AI folder, we are going to right click and go to Artificial Intelligence Behavior Tree. We can name this whatever we want, but why don't we, let's see, let's call this character that we're fighting a orc. I'm going to call this my orc behavior tree, so orc BT. And if we double click on it, this is our behavior tree editor. Now, what the behavior tree editor is it's a slightly different approach to scripting. So the root is going to be called constantly, like every game tick, I believe the root is called, and then the root can have these child nodes coming out of it. In addition to our behavior tree, which contains the code for how our character behaves, we also have to create something called a blackboard. So if we right click, we can go to Artificial Intelligence Blackboard. A blackboard is you can think of it like a database of information that we use while calculating artificial intelligence behavior. So it's essentially just an object that can contain lots of different variables. I'm going to name this orc blackboard. And if we go in here, we can create all of the variables that we need this blackboard to hold. So these can be things like, well, our orc, if it's attacking something, it needs to know what it's attacking. So we're going to add a new key in here so that the orc remembers the thing that it's attacking. So the thing should be an object, and we can call this our target. Or if we want to name it a bit better, how about our attack target? If we switch over to our behavior tree, there is a spot over here for our blackboard asset, and we can click and assign our orc blackboard as the blackboard to use in this behavior tree. All right, I kind of made a mistake there. So in the orc character, what we want to do is maybe tell it the default thing that should possess it. So, right now we can have players possess this character, or we can have an AI controller possess it. And we don't really have any AI controllers that we've written. So we're going to come out here and create a class that is a subclass of AI controller. We're going to name it our orc controller. And this is the object that is going to possess our orc character in the game world. So if we grab our orc controller, we can go to its event graph and tell it to use that behavior tree we created. We can say run behavior tree. and the asset we want is our orc behavior tree. And there you go. Our orc controller is pretty much done for now. Our orc character, what we want to do is say any orc character should automatically be possessed by an orc controller. So in the orc character uh, blueprint, we're going to look over here for AI controller class and say that we're going to use our orc controller that we created. And we can compile and save this. All right, let's go ahead and program our behavior tree. All right, in our behavior tree, first thing we want to do is come over here to the details and tell it to use the blackboard that we created. And then you'll notice the behavior tree, it's called the behavior tree because it is a tree-like structure for logic. So there's this root node, and then kind of these branches come out of the root node. So we've got these different composites to choose from, and a composite allows us to run one or more child nodes. So let's just put in a sequence. And we'll say that the first thing that this object does is it's going to make noise, and then it's going to move directly towards something, a target. If you notice that there's actually an input to this task where it says move directly toward, and currently it's invalid, but that's okay. So what we're going to do actually is with this node selected, we can come over here and we can tell it for this input of move directly toward, we can set up a blackboard key. So move directly toward, we can set to an object that exists inside of a value that exists inside of our blackboard. We have attack target here. And we're going to say that it can store a character object. If we save this, we should be able to pull it up over here. We should be able to pull it up in our move directly toward as the key that we're passing in. However, this doesn't seem to work here. Oh, it probably requires not an object key, but it probably requires a position key. Let's try something. Let's add in a vector, and we're going to say attack target position, and a vector is perfect. We can save this, and if we go back to our behavior tree for our move directly toward, it's still not popping up. Let's add in a vector. Oh, there we go. Just save and reload. So I was editing my behavior tree and my blackboard in two different tabs, but you can switch between them using this button right here after they're linked up. And for whatever reason, that seemed to work fine. So now my move directly toward is moving directly towards whatever is stored in my attack target. I'm not currently storing anything inside of that attack target variable, so we need to do that. Before we can do any of the child nodes of the sequence, we should first give it something called a service. So we're going to right click and add a service, and there's a couple that are built in, but we're going to make our own. So we're going to click new service, and it just created an asset that it put inside of our content browser, and it named it BT Service Blueprint Base New. We're going to rename that, and this is going to be our aggro check. The aggro check is going to check to see if there are any targets nearby, and if there are targets nearby, it's going to essentially assign them into that attack target variable inside of the blackboard object. So back in the aggro check, we're going to test this real quick by adding some events. And I don't remember if these services, if they run on receive tick or if they run on execute. And it looks like receive tick because I'm not seeing an execute in here. So on event receive tick, we're going to do the following. And for starters, we're just going to do a print string that prints out am I aggro. I want to see if this works, so we're going to save this. And back in our behavior tree, we're going to right click and add this service, aggro check, to our sequence. So what happens is the root, every frame is going to tell the sequence to run. And the sequence, before it tells any of its children to run, it's first going to do an aggro check. And it looks like the aggro check happens randomly between every 0.4 and 0.6 seconds. And you can change that over here if you want. Obviously, this is an optimization. If our game is running at 60 frames a second, we probably don't want to be doing the aggro check every 0.016 second. So this allows us to optimize some of that logic. And after it does the aggro check, it's going to call make noise, and then it's going to call move directly toward. So let's go ahead and save and play our game. And it looks like our guy, oh, you know what? We don't have an orc in our game world. That's probably an issue. So if we come down here, notice we've got two of our player characters. I guess here they're called third-person character. We're going to delete the second third-person character, and we made our own orc character that we can drop in instead. Now our orc character looks like it doesn't have any sort of skeletal mesh assigned yet or anything like that, so it looks kind of dumb. We can't see it, but it's over there, and it is doing its aggro check every half second approximately. Let's see if we go into the orc character class. And we go to its mesh. We could give it a skeletal mesh of this mannequin. And we want to also give it an animation blueprint. We're going to tell it to use the same one that we're using for the player. I'm just got to copy over the settings from the player class. So a third-person character, and if we select the mesh in here, it's using third-person anim bp underscore c. So let's drop that into our orc as well. Third person anim bpc, there we go. And we're just going to move him down. And it looks like he's not facing forward, so we're going to rotate him 90 degrees. And that's a pretty good start for our character. It might be a little large even, but it's probably okay, right? He's an orc, so it's fitting. So there's the orc, and he's asking, am I aggro? So if we go back into our behavior tree, you know, we're not sure if this is working properly or not. I mean, obviously the aggro check is running, but we don't know if move directly toward is running yet. If we go into our aggro check, what we want to do is we want to set that blackboard variable, the attack target, to our player. So we could just do that directly and say set blackboard value as, and the attack target key inside the blackboard was an object. So we're going to call set blackboard value as object. We have to pass in the key, and we have to pass in the value we want to set it to. So what we're going to do is every time this aggro check runs, we're going to grab our player character, and we're going to set it up as the value that we set our blackboard key to. Now here's the thing, this is a little weird, but what we're going to do is pull out from key, and we're going to create a variable, and we can call this variable whatever we want, but obviously we want to name it something smart. So we're going to say attack target, and I think we're good. Let's make it public so that we can see it, and click compile. Now what we're going to do is we're going to go back to our behavior tree, select aggro check, and since we made a public variable called attack target, it shows up right here and right over here. And what it's going to do by default is grab the first key inside of the blackboard object, which happens to be attack target. That's perfect. So essentially this behavior tree, when it runs move directly toward, it's going to pass in this blackboard key and assign it to the local variable inside of this task. It's going to assign it to its attack target. So if we save and run this, you'll notice that the orc starts chasing me. All right, so these behavior trees can get really, really complex. We don't have to make them super complex in order to start working with them. This make noise, I just put in there as an example because I wanted to show you how these composite nodes actually work. And the composite nodes can have lots of different child nodes coming out of them. And the way they work is they run them from left to right. So first it would run make noise, then move directly toward, and then play animation. These nodes can succeed or they can fail. With a sequence, the sequence runs every single node until it finds one that fails, and then it stops. And the failure goes up the tree. So if this sequence was being called by another sequence, this sequence would return that it has failed, and basically that's the way the message gets communicated up the tree, and then the tree decides what to do next. There's another kind of composite node called a selector, which is kind of the opposite. It runs every child node until it finds one that succeeds, and then it stops running child nodes and it reports that success up the tree. So this is a pretty good start. What we want to do is we want our characters to be able to attack one another. And I believe for your games, we want mostly melee attacks. So what we can do is we can go into our character class and we can either, when we attack, we can shoot out a projectile, but that doesn't make sense for melee. Or we can do a raycast. Raycast makes sense, but it could be kind of tricky. And the other thing we could do is we could essentially try to create like a large volume in front of the player and basically check to see what objects are in that volume. I've done the first two approaches, but I haven't done the third. But let's go ahead and try the third and see if it works at all. So what we want to do is to our player, we want to add a component. And that component could be, for example, a cone. Hold on, that's actually a cone that gets rendered. What we want is something that people can collide with. So our collision options are box collision, capsule collision, or sphere collision. So already we're kind of limited. Let's try a box collision for proof of concept here. So essentially what we're saying is when we press the attack button, we want to damage anything that's inside of this volume. What we will need to do is get a list of objects inside this volume. And unfortunately, I don't think that is something that's built in. We're going to have to program that logic ourselves. What we have in terms of events here is we're going to listen for when objects start entering this volume, and we're going to listen for when they stop, when they exit the volume. So I'm going to add a begin overlap, and let's see, click on the box. I'm going to add an end overlap. And what we'll do is inside of our player, we'll keep a list of all of the objects that are inside the volume. So we're going to come over here and add a new variable. And I called the variable objects in front of player. What we want to do is change the data type to actor. So it's going to be a list of all of the actors in front of the player. And it can't be a single object. It needs to be an array of objects so that it can hold more than one. And now we've got our array of objects in front of the player. Whenever an object begins overlapping the box, what we're going to do is we'll grab our array. We're going to add an object to the array. In fact, just so we don't get any duplicates, instead of add, I'm going to call add unique. And hopefully that works the way I think it works. So we're going to add the actor that began overlapping into our list of actors in front of the player. Similarly, when an actor stops overlapping the box, we're going to remove them. And if this is done correctly, it should maintain a very accurate list of actors in front of the player. So when our player goes to attack, we can see what those objects are and we can do damage to them. So I'm going to go to my project settings, and in the project settings, I'll go to the input mapper. We've got jump and reset VR. We've got some axis mappings. I'm going to add a new action mapping called attack. And what we'll do is we will make that the mouse click, left mouse button. And now, inside of our player character, we are going to listen for that event. So when the attack button is pressed, what we want to do is loop through all of the objects in front of the player and damage any of them that can be damaged. So we grab a reference to our array of objects, and we're going to loop through it. Let's do a for each loop. And let's see, we'll grab this object. And what we want to do is, of course, call a function on the object like damage or hurt. Let's go ahead and call damage. You'll notice that there is, well, actually, I guess there is a apply damage built into the engine. But we're going to go ahead and run our own solution here. So we don't really know what kinds of objects are in front of the player. It could be pawns, it could be dynamic objects, physics objects, it could be static scenery. So what we're going to have to do is take whatever this object is and cast it into the object we think it might be. So if we go into the orc class, we're going to give this orc a function that allows us to damage it. In fact, if we come over here to functions, we can click add function, and we'll name this take damage. And we probably want to know how much damage it should take, so we're going to click the new parameter button here, and we'll pass in a parameter called amount, and it will be a float. Our orc needs to keep track of how much health it has, so let's add a variable, not a local variable, but a variable, and let's call this health. Health should be maybe a integer or a float. And once we compile, we can set the default value to 100. All right, when we take damage, we should subtract from our health. So we're going to set our health equal to health minus amount. Whenever we take damage, we should probably check to see if we're dead. So I'm going to make a new function because encapsulation is a good thing here, and we can name this function check death. Oh, named it wrong. So what we're going to do is see if our health is less than or equal to 0. If our health is less than or equal to 0, then what we'll do for now is we'll just go ahead and print out a string that says I am dead. And we can compile this. Now, we have this take damage function, we have this check death function. As long as the object we're working with is an orc, we should be able to call these functions. So back in our third person character, when our player tries to do damage to the object in front of it, we're going to check to see if that object is an orc. So we're going to go ahead and do something called a cast. We're going to cast this object to an orc type. And if that cast is successful, we know that it was actually an orc. So we're going to go ahead and say, well, if it is an orc, that orc should take damage. So I'm going to go ahead and pull out this reference to the orc and call its take damage function. For now, let's just have it take 50 damage, and we'll compile our code. I'm going to do something. I'm going to go into aggro check, and oh, I guess we already took that out. We took out the print. So let's go ahead and play our game. And so the orc runs towards me, and if I click a couple times, oh, it's not working. Let's find out why. We go to orc. No, if we go to player, input action attack, print, and we're going to say attack. All right, so these print strings have kind of proven that at least for pawns, they are being added to our list. If the kinds of objects weren't being added properly, we could actually go into the box's collision settings, and we could change which objects trigger an overlap and which ones don't. Right now it's set to overlap all dynamic, and so I think it's ignoring a lot of that static world geometry. It is, however, working with our orc. So we know this part's working, but this happens, but we don't know if it's taking damage. In fact, it seems like it's not taking damage. So that's a little curious. Let's find out why. We're going to maybe do a print here, and we're going to print out ouch. And just to kind of clean up what we're seeing, I'm going to take these prints off, and we can compile and play and see. Okay, so we are hitting this guy. Oh, I know what we're doing wrong. We're not doing anything wrong, actually. We just forgot to call check death. So whenever we take damage, our orc should probably check to see if it's dead. Oh, no, not take damage. Check death. So whenever it takes damage, it checks to see if it's dead, and if it's dead, it prints out I am dead. So if we play, there we go. After a few hits of 50 damage a hit, the orc is dead. So this approach works really well. And when I say this approach, I'm talking about having this invisible hit volume in front of the player. It's not a perfect solution for all types of combat, but it is pretty simple. It doesn't require a lot of programming, like a raycast might require more. In fact, I really like the way that this is turning out so far. So from here, what should you do? Really, what we're missing is we're missing the concept of a weapon. And so if I were you, I would maybe create a new actor. Oh, let's see, let's go blueprint class. Or I guess we could also create a component that goes inside of our actor. I haven't tried one or the other. Well, for my game King Kitty, I created actors and I attached them to the player, as opposed to creating components and attaching them to the player. I think either approach would work. In fact, let's try the actor component to see what we can do. So we're going to make a weapon component. And here it is. There's not a whole lot in it yet. But let's go back to our player and let's add our weapon component to the player. So now every player has a weapon. Anything that all weapons should do, we can add that code in here. So every weapon should be able to do damage to an object. So let's create a function called do damage to. And what we need to know is we need to know what object to do damage to. Oh, let's see, do damage to, and we need, let's see, an orc object. So when this object does damage, well, when this function is called, it's going to call the orc's take damage function. Okay, and how much damage it should give the orc should vary. Some weapons should do more damage, other weapons should do less. So what you can do is add a variable in here called damage amount. So every weapon has a damage amount. So we'll give it a float, and that's how much damage we should do to the orc when do damage to is called. Okay, well that works well. Default value, let's make 10. And let's see, this is a pretty good start. If we go to our third person character, we grab our weapon component, we can see that the damage amount is actually right in here, so we can change it. And we'll change it more later if we want. So by default, the player's default weapon damage of 10 is fine for this particular weapon. If we go back into the player's code, we no longer want the player to directly damage the orc. We want the player's weapon to damage the orc. So what we're going to do is not call the orc's take damage function, but instead we're going to call our weapons do damage to function. So whatever our weapon is, we're going to tell our weapon to do damage to this object because it is an orc. And that should work pretty well. I'm going to take out this attack. We know that's working, so we'll take out that print line. And if we go back to the orc class, what we can do is every time it takes damage, we can have it print out what its current health is. So we'll just do actually I don't want to do that. I want to do a print string, and the string we want to print out is the orc's health. And if we hit play, 90, 80, 70, 60, 50, and then he's dead. So our 10 damage weapon is working great. Oh, actually, I'm going to leave that in. Yeah, perfect. Yeah, perfect. Yeah, perfect. Yeah, perfect. Yeah, perfect. Dead. So our leave that in. Yeah, leave that in. Yeah, perfect. Yeah, perfect. So now I'm going to right click and make a new class based off of actor, and we're going to call this weapon. And the weapon actor can have code like any other. So we're going to go to function and call our do damage to function, or rather we're going to declare it. And we can say we want to do damage to an orc. In fact, let's rename this from do damage to do damage to orc, and then we can have other functions that do damage to other kinds of objects. We're going to pass in an orc object that we want to do damage to, and then for that particular orc object, we're going to call its take damage function. And the amount of damage should be equal to a variable we create called damage amount. We can rename this into or change it into a float. Get it, set it, forget it. Change the default value to 10, save it. Okay, there's our base weapon class. Now we can right click and we can create an additional class based off of that. So we're going to build a class based off of weapon. We're going to call this weapon bastard sword. Weapon bastard sword, if you go to class defaults, we can change its damage amount to 25. And now what we can do is go to our weapon component, and we can add a variable. And that variable would be the kind of weapon that this weapon component is holding. I know, it's a little confusing. So we're going to change the data type to weapon, a weapon object reference. And our weapon component, if we open it back up, can hold a weapon. But what we're going to do actually is add a function that allows us to equip a new kind of weapon. So we're going to name the function to equip, and we need to pass in the type of weapon we want to equip, and then we'll spawn it. So what we're going to do is our input here is going to be, we're going to call it weapon type, and the data type is going to be weapon, but not a specific weapon object. If you click over here on the right, we have a class reference, and that's what we want. We want a reference to the type of object. And so if we grab this type, we can actually call our, what is it, spawn actor from class. And this will spawn a new weapon. If the weapon has any visuals, like any mesh we want to render, we can change its transform and do all kinds of interesting stuff. Like we can attach it to this object so it moves with it. I'm not too worried about that quite yet. I'm more interested in getting the gameplay running. So after we spawn this actor, we're going to set our weapon equal to it, our weapon variable. So there we go. Now this isn't going to work because we need to have a spawn transform set. We can probably split this, and I think that will be just fine. There we go. So default location, rotation, scale. It's going to spawn at the world origin. But right now, the location of the weapon doesn't matter. So there we go. Our weapon component can spawn, it can equip and spawn a new weapon. So we are now going to make a function called attack. And what's going to happen is we're going to move this code over from our attack that's inside of our inside of our player. In fact, we can probably move all of it. So when we tell our weapon component to attack, what it's going to do is take all of the objects in front of the player and see if they're orcs and then try to damage them. But here's the problem. It can't see this variable. In fact, if we were to compile it, it would be really confused. It's like, what do you mean? There's no variable over here called objects in front of the player. Well, that's fine. We're actually going to change our parameter for this function, and we're going to pass in an array of objects to attack. So we're going to basically say, we're going to pass in not a single object, but an array of them. And this will be the array that we do our for loop for. Okay, now sometimes with functions that take arrays like this, you need to recreate them. They won't take new arrays after you generate them. So I'm going to grab this. And by the way, double check it is an array of objects. What do we have in our third person character code? This is an array of actors. Oh yeah, that's what we want. Okay, well I'm going to change this from array of objects to array of actors. There we go. And then it should, yeah, perfect. And we can name this objects in range. Ooh, actually this is giving me an idea, but I'll come back to it later if there's time. So now this is pretty simple. We've moved our code into our weapon component. This should only work if there is a weapon set. So what we might want to do is just have an if up here. This is just for safety so that our game doesn't crash. And what we want to do is actually say if weapon is valid. And in fact, there's a function you can call, but there's also this built-in if statement. So we can get rid of our branch because this is essentially a branch. It's saying if our weapon object is an actual object, then do the following code. Fantastic. We can compile it, save it, go back to our third-person character. Our third-person character has a weapon component. And so what we can do is when we press the attack button, we can tell our weapon component to attack. And then we have to give it the list of objects that are in front of the player. All right, pretty simple. Let's go ahead and compile this and see what we did wrong by running it. And let's see, we're not damaging this guy. Oh, and I know why. It's because our weapon component starts off with a default weapon, and we never call the equip function. So, how are we going to equip a weapon? We have to call the equip function, obviously. So if we go to our third person character, we could create the interface for doing that in here, and that would be a good idea. It would make sense for us to tell characters to equip weapons, and then they would tell their weapon components to actually equip the particular weapon. What I'm going to do for now is just say that when the game begins, we're going to equip a default weapon. So in the third person character class, we're going to get rid of this weapon variable. In fact, we can reuse it. We're going to rename it to default weapon. And it's not going to be an actual weapon. It's going to be a weapon class reference. So again, we want to store a weapon type. So any kind of class that is weapon or a subclass of weapon, we can store in this. So for the default value, we can set this to weapon, or we can set it to bastard sword. So we can set it to weapon, and then when the game begins, we can tell our character to equip the weapon. In fact, I'm going to make a function in here called equip weapon, and when we call that function, we're going to pass in a type of weapon. Oops, yeah, weapon class reference. In fact, I'm going to name this weapon type. So when a weapon type is passed in, what we're going to do is call our weapon components equip function, and we're just going to pass in the type that we want to equip. Remember, the weapon component is then going to spawn that weapon and then equip it. Okay, well, what we're going to do is when the game begins, we want our player to automatically equip their default weapon. We don't have a on begin, so we're going to add one. Just going to add it down here. We can right click and say begin play. And when we begin playing, we're going to call our equip weapon function. And the weapon we want to equip should be our default weapon. And compile, save, play. There we go. I can now do damage to the enemy. Now the cool thing is if you make default weapon public, and then you can change it per instance. So what this means is that if you have, if this wasn't the player, if it was the orc, you could click on a specific orc in the game world and then set its default weapon. This doesn't make as much sense with the player, but you get the idea. Okay, so we do have something of a memory leak. If we go into our equip weapon function, if we go into our weapon components equip function, it spawns a new weapon, but it doesn't get rid of the old one, and that's problematic. So after we spawn the new weapon, if that weapon is valid, we're going to destroy our old weapon. In fact, just for us to make heads or tails of it, I'm going to make a new function for doing that. So new function and destroy old weapon. So we're going to basically say if our old weapon is valid, then we're going to remove it from the game world by calling its destroy function, destroy actor. And when we do that, we also will probably want to set our weapon variable to null, if it'll let us do that. Okay, so now we've got this destroy old weapon method, and we can go into our equip method and say whenever we're about to equip, first thing we're going to do is destroy our old weapon before we equip a new one. And just like that, I think we've fixed our memory leak. And what next? Yes, let's go ahead and test it. I'll walk over here, hit this guy with the bastard sword, and he's dead. From there, we can start creating more weapons. It's pretty easy. In fact, we probably want to give the orc a weapon as well. So what we can do is choose our orc. In fact, let's go into our orc's blueprint. And we're going to give the orc a weapon component. The orc, I did a lot of this on the player, and I should have done it on the orc, but this is good. It's good practice. We're going to add a variable, and this variable is going to be our default weapon. And what we can do is set this to our weapon class reference. And we can say the default weapon is just the base weapon, 10 damage. We want to make this instance editable, so click the eyeball so that every weapon we can, or every orc, we can set its default weapon. Let's add an equip weapon function. And when we equip in a weapon, we're going to set the weapon type we want to equip. This is going to be a weapon class reference. And what we'll do is pass that on to our weapon component. We're going to call its equip function. And when the game begins, we will just tell this object to equip its default weapon. So we're going to grab our equip weapon function, and we'll say default weapon. Okay. So now our orcs have weapons as well. They do not have the intelligence, the artificial intelligence in their behavior tree. They don't have that available to attack yet. And so what we probably want to do is go into our behavior tree and edit that. All right, so we kind of want to think about how this logic works. We only want the orcs to attack if they're close enough to attack. We're going to create a different service called attack or close enough to attack or something like that. So back in the blue, not the blueprint, the behavior tree, we're going to say new service, and okay, well that button's not working the way I want it to. We're going to right click and say new blueprint, and this is going to be a new BT service blueprint, and we're going to call this not aggro check, but I guess attack check. Yeah, that works for me. So the purpose of the attack check is to see if their attack target is close enough for them to hit, and that's not the code I wanted to paste. We're going to say on event receive tick, do the following code. The following code is for us to, first of all, we need a get value from oh come on, get blackboard value as object. Okay, and no, not set. We're getting close, guys. Get blackboard value as object. Okay, there we go. And we need to create a variable to store a key, and this will be our attack target key. Okay, there we go. And our attack target key is going to return an object that we will cast to an actor. Right? Okay, so the thing that we're trying to attack, we have a reference to it right here, and we're basically going to say, does this particular object exist inside of our attack zone? So if you recall, the orc has an attack zone. It is, oh, the orc doesn't have an attack zone. That's right. This is kind of annoying because we built a lot of this logic inside of our player class, and we have to rebuild it inside of the orc class. Now, what I would recommend is a little bit of refactoring. Since our player and our orc contain so much similar logic, they should both be derived from the same base class. Oh, screw it. I'm gonna I'm gonna try something. I'm gonna go orc class settings, and we're gonna set it as its parent, not as character, but as third person character. All right, now this is a little confusing because now it already has a weapon component that it has inherited from third person characters. So we're gonna get rid of weapon component 1 and see if we can compile. We still have an error. It says equip. Oh, there's already a function called equip weapon. So we don't want to redeclare equip weapon. Let's grab the equip weapon we've redeclared and delete it and compile. And there we go. It's now working just fine. But let's see if it actually works in the game. The orc still, it is possessed by our custom AI controller, and it works great. So the benefit here is now every single orc has all of the logic that we put inside of our player class. So when we want, we want orcs to be able to attack, we want the player to be able to attack. There's a lot of the same logic there. All right, so what we're going to do now is we're going to make a function that checks to see if an object is in front of the attackable volume. And that should be defined, of course, in our player class, since it's the owner of the attackable volume, which we should rename from box to attack volume. All right, now it's named attack volume. What we want to do is find out if an object is in here. So we're going to make a function is actor in attack volume. So we have to pass in the actor we want to check. And its data type should be actor, of course. Should be a reference to a specific object. And what we're going to do is basically ask, is this object inside of this array? That's all we got to do. So we're going to say contains. Yeah, perfect. Does this array contain this item? And it returns a true or false, and that's what we want to return out of this function. This function doesn't have a return setup, so what we're going to do is set up an output. I just called it results, and it needs to output a Boolean, true or false, and it will output this particular value. So if this actor is inside of the array, it returns true. If it's not, it returns false. Awesome. So now we can use this in our attack check service for our AI system. So we're going to say we are inside of attack check, which is being used inside of a behavior tree. The behavior tree is being used by an AI controller that we wrote called orc controller, and that orc controller has a orc pawn currently possessed. So it's kind of complicated. We want the orc pawn, we want to call its function for checking to see whether or not that object is inside of it. Wow, okay. So how do we do this? Let's try get controller actor self. That's not quite what I want. I'm trying to remember exactly what I want here. How about possessed pawn? No. Get control. I thought I want get controlled actor, but it's not popping up. Let's try owner actor. Oh yeah, let's see. We have to. Let's do something. When we do our attack check, I want to print out what the owner is of this particular script. So I'm going to print out the actor, okay, like so. And I'm going to save this, and I'm going to put the attack check in our behavior tree. So just right click, add service, attack check, and save it. Run the game. Cool. So that particular object is our orc controller. So what we're going to do is, I know this is a little, it feels like a runaround, but we want to cast this as an orc controller. Actually, we can just cast it as any kind of controller. And from there, we can grab the pawn that it's controlling. So get controlled pawn. And the pawn is the orc in this case. And it should have that function that we wrote because it is inheriting it from the third person character. That function we wrote was called is actor, what was it called? Is actor in attack volume. Oh, okay. So I see the problem here. That particular method isn't defined in the pawn class. It's defined in the third person character pawn class. So we need to actually take this pawn and we need to cast it to our third person character. Okay, so essentially, if the if the actor using this service is a controller, and if its pawn is a third-person character, we can then call that third-person character's function called is actor in attack volume. And the actor we want to check is, of course, the attack target that's stored inside of our blackboard. So we can move this over here and we can say that's the actor we want to check. We need to do a cast here. Okay. And let's see, if it is, then we're gonna go ahead and say that we are ready to attack. Okay, so what we want to do is make a new value inside of our blackboard that stores whether or not we're ready to attack. So if we go to our behavior tree, click on blackboard, we can add a new key. We don't need this attack target position. We're not really using it. We're going to make a new key called, well, I guess it's a Boolean, and then we're going to call it ready to attack. Okay, so what we want to do now is we're going to set that value inside of our blackboard. So set blackboard value as a Boolean. It's a Boolean key. And we need the name of the key, and that's going to be passed into this service. So we are going to promote this to a variable and call this our ready to attack key. And there we go, ready to attack. Maybe, depending on whatever this value is, we're going to set ready to attack equal to it. Bada boom, bada bing. There we go. Let's see, anything else we got to do? Save, compile. We got to go back to our behavior tree, and now our attack check. Oh, we got to make attack target and attack ready to attack. We got to make these both viewable and then compile. And then back in our behavior tree now, our attack check requires those as inputs. So our attack target is going to be the attack target value inside of the blackboard, and our ready to attack is going to be our ready to attack value inside of the blackboard. All right, what we can do is we can make a new task called attack. We haven't made a task yet, so we're going to say a new task, and I want to rename this from BT task blueprint base new, and we can right click on it and say attack. All right, this task inside of our behavior tree will receive a node called begin execute or receive execute. And it needs to fire at the end in end execute. Oh, what's it called? Finish execute. This tells the behavior tree whether or not it was a successful attack, which, I don't really care either way, but it needs to be there. So what we're going to do is say when we are trying to attack, when we're calling our attack task, let's check that key inside of the blackboard. So the key, of course, was called ready to attack. We're going to get that value from the blackboard. So this is get blackboard value as bool. And the key that we want it should be made public, and I'm going to call it ready to attack. That will give us a Boolean, hopefully. And we can essentially set up an if statement here and say if this is true, then we want to tell our pawn to attack. And our pawn, we're going to get the same way we did in our attack check, which is to get the actor here and cast it to a controller. And once we do that, we're going to get our controller and get the pawn inside of it. Get controlled pawn. And then we're going to take the pawn and we're going to cast it as our third person character, because our third person character has the attack function built in. And then we're going to tell our third person character to attack. Oh, actually, I guess we're going to tell the component inside of the weapon component to attack, which is fine. That works just fine. All right. When this is all said and done, we need to call our finish execute. And what we need is we need to make sure we call this finish execute no matter what. So when any of these branches happen, they also need to end up calling finish execute. And what we can do is uncheck success, meaning that if one of these things didn't happen, then we did not actually do an attack. And that's useful information in our behavior tree. All right, we have an error. Objects in range pin is invalid. Oh, okay. So when we tell our component to attack, we have to give it all of the objects that are inside of the actor. This is a little bit messy. So what I'm going to do is go into third person character, and we're going to add a function called attack. And all that attack is going to do is it's going to tell our weapon component to attack. And it's going to pass in the objects that are inside of the range of this particular character. Here we called it player, but this really is for any, this is being used as a parent class to orc, so maybe we should rename this objects in front of character. All right, back in our attack. We are not going to tell our weapon component to attack. Instead, we're going to tell our third person character to attack, and they will tell their component to attack. We'll just handle that. There we go. That's a little cleaner. So I don't know if this guy is attacking me or not. And here's the reason why. He's not attacking us, because the attack function right now inside of our, where is it? Inside of our weapon component only attacks orcs, and the player is not an orc. So we're going to go into our weapon component, and go into its attack function. And we're not going to treat the object we're attacking as if it were an orc. We're going to treat it as if it were a player character, or not a player character, but a third-person character. I should really rename that, so it's less confusing. So if we go into our third-person character and we go into our orc, all third-person characters need the ability to take damage. So we're going to move this take damage function. We're going to move it out of orc and into third-person character. So I'm just going to copy everything here. And in third-person character, we're going to say new function, take damage, and then paste. We need to say how much damage. So I'm going to pass in an amount into take damage. Our character doesn't have any health yet, so we need to come down here and add a variable for health. And the check death function also needs to be moved over, because any kind of object can die. Any sort of character can die. That did not work. Hold on. All right. Let's compile this. We got an error. Oh, health 0. We're just going to replace that with our local health variable. Compile. All right, we're good. We compiled. Go to the orc class. We have some issues. Take damage and check death, we now no longer need in here because those are being inherited. Health we no longer need because that's being inherited as well. Compile. Let's see. You know what? Default weapon is also something that's being inherited from our character class, so we don't need that. Because all of our third-person characters, when they spawn, equip their default weapon. Awesome. Let's see, do we have any issues? Weapon component has an issue. Do damage to orc no longer exists. Well, let's see here. This is in the weapon class. So if we were to go into our weapon class, take damage is no longer in orc. So what we want to do is we want to rename this function from do damage to orc, and I want to name it do damage to character. And the character we want to do damage to is not an orc necessarily, it is a third-person character. Okay, and we're going to call its take damage function. All right, and then in our weapon component, we're no longer going to cast the object we're trying to hit to an orc. We're going to cast it to a third-person character. Awesome. So if we save it and we come out to our map, let's give our orc a default weapon. Oh, it does. It has a weapon object. We hit play. Oh, I know what we did wrong. We have to go to our behavior tree. And we need to add attack into our behavior tree. So I'm going to take make noise out. I'm going to take play animation out, and I'm going to add a attack task, and we need to pass in the ready to attack value from our blackboard. And now I think we're ready to play. All right. It took me a while to figure out. There were a couple issues that are preventing the attack from happening. Um, so first of all, one issue was that the orc had a begin play node in here, and it was overriding the begin play node from its superclass third person example map, or third person character. So I just got rid of that. And then the other problem is that when our third person character takes damage, we were no longer calling check death. So if I drop check death in here, and I'm going to give the orc, I'm going to give it a bastard sword to start with, and then we can save it and hit play, and there you go. He runs over, hits the character 4 times very quickly, and then they die. By the way, you might want some sort of cooldown to prevent that from happening. Um, Finally, what you probably want is you want some sort of stealth system built into your game. So we're going to take the orc and move it over here. And we want the orc, we don't want the orc to see the player. So how are we going to accomplish this? So if we click Add Component, there's a section in here for AI. And what we want is an AI perception component. Now I'm in the orc class. So this means that orcs will be able to perceive objects in the environment. So come over here to AI perception, and you'll notice we actually have to add different senses. So if you click Add, you can add the sense of sight. And then there are some settings you can set in here for that sense. One of the things you'll want to do is you'll want to go to detection by affiliation. Right now, inside of the game engine, there is the ability to create different factions. So the defaults are enemies, neutrals, and friendlies. Unfortunately, you can't set an object's affiliation inside of blueprints. You can only do it through C++ code. So this whole system, we're going to have to recreate using our own logic inside of blueprints. Just check all of them so that it ignores the built-in affiliation data. Okay, we're also going to give another sense. We're going to add the sense of hearing. And again, come in here and turn on all affiliations so they can hear all factions. You can set things like how far it can hear and stuff like that, but I'm not going to tweak it too much right now. Okay, so now what we want to do is actually listen for an event for when this object senses other objects. If you look down here, we've got perception updated, component activated, on target perception updated. We're going to try on perception updated and see what happens. I'm going to put in a print, and I'm going to print out I sense something. We compile this and press play. Oh, you'll notice that our orc did sense the player. And the reason why they sense the player is because the current AI has them automatically target the player. So right away it turned around and saw me. If I go to our behavior tree, I can actually go into our aggro check and have it not sense the player automatically. I just disconnected that. So now the orc doesn't turn around and see me. And if I get close enough to where I'm in the orc's cone of vision, it will sense me. You'll notice that this event is called when it starts seeing me or sensing me, and when it stops sensing me. So when I go out of its cone of vision, this is updated. If we try this other event called on target perception updated, it will tell us specifically which object it started or stopped sensing. So what we can do is maybe print out that actor here. And see when it starts and stops noticing this particular actor. And if you split the input pin here, stimulus successfully sensed is true if it started sensing something and false if it stopped. what we can do is, if you wanted different NPCs to fight each other, every NPC could have a list of all of the actors that it, is currently sensing. But we're going to skip that step. We're going to try to go a little bit more simple. Currently, we just want our orcs to sense the player, and if they sense the player, we want them to start attacking the player. So what we can do is we can maybe check to see if the actor they sensed is in fact the player. So we're going to say if it started sensing something, and if the thing it started sensing is the player, then we can say that they're ready to attack the player. So we're going to put maybe a variable in here. Maybe we can call it aggro, which might be a little confusing considering we've got an aggro check inside of our behavior tree. But this is going to be purely whether or not the AI can sense the player. So we're going to say if they ever start sensing them, then aggro becomes true. And for this current example, actually what I'll do is if they stop sensing the player, we'll set aggro to false. It's just for the ability for the player to hide. So that should work pretty well. We can compile that. And if we go into our aggro check function, we only want to set our attack actor to the player character if the pawn can actually see the player character, if their aggro value is set to true. So what we're going to do is get the owner actor, which is a AI controller. So we're going to actually cast this to a controller. And if that is successful, we're going to ask for the controller's controlled pawn. And then we're going to cast that to a orc. Okay, if that cast is successful, we're going to check to see the orc's aggro state. And if the aggro is true, we want to set the attack target to the player character. If it's not true, we probably want to set it to null, nothing. So I'm actually going to put an if here. And say if our orc is aggro, then we're going to set its attack target to the player character. And then I'm going to maybe copy some of this code. I'm going to get rid of the comment though. I'm going to copy this code. And if aggro is false, we're going to set the attack target to nothing. All right, so now if we play, we're not being attacked. But as soon as the orc sees us, it starts attacking us. Now, if the orc was slow enough, I could hide from it. Unfortunately, well, hold on. There we go. So I was able to hide from the orc. Oh no! All right. It doesn't like the way that in aggro check I'm setting the attack target to nothing. It's kind of just ignoring that apparently. So what we want to do is we want to do something a little different. We're going to go into our behavior tree and we're going to make something called a decorator. And a decorator is, you can think of it as like a branch, an if. And we're going to use it to essentially check to see whether or not the character is aggro. before we allow them to attack. All right, so the way that the decorator works is a little funny. You go over to functions, you click override, and we're going to override the perform condition check. Okay, this is a function that we call that returns true or false. And what we're going to do is we're going to grab the controller. We'll basically cast this to a controller, and we're going to get the controller's control pawn. We're going to get the pawn to cast it as an orc. And from there, we're going to check to see if the orc is aggro. And that's what we'll return from this function. Now, it's important here that since this function needs to return something, that we duplicate the return node, and if we fail to cast to an orc for some reason, which shouldn't happen, and if we fail to cast to a controller for some reason, which shouldn't happen, we just return something as well. In this case, we'll return false. All right, compile, and what we can do is actually rename this. So instead of BT decorator blueprint base new, we're going to rename this to, I want to name this check aggro, but I already have one called aggro check, which is really confusing. I'm going to name this check can see. Okay, so this is checking whether or not whether or not they can sense the player. So in the orc BT, we got a sequence here. We are going to right click and say add a decorator check can see. If this returns false, then the tree shouldn't do anything after that. What we want to do though is of course make sure that our attack target, well, that should be fine actually. That should be just fine. So if we hit play, you can see us, and oh, come on. All right. In order to get this working, I had to move the decorator out of this root sequence node and put it into a child node. Apparently the decorators don't work if they're in the very first object, the very first node that comes after root. So with this, you'll see that the game now works. He can see me, and then as soon as I get out of his cone of view, he can't see me anymore. This needs a little bit of work to get it, probably fully to exactly where you want it. Otherwise, you can just kind of run behind him and he stops seeing you. So there's some playing around with it that you can do, especially in some of the blueprints code. But it does allow you to have some basic stealth mechanics. One of the things that you'll want to play around with, of course, is sound. And by default, none of the characters make any sound. You'll remember that we did set up the AI perception to hear any sound, but nothing makes sound. So if I go into the third person character, we can give them a component called pawn noise emitter. And what we can do is occasionally tell that noise emitter to make noise. So for example, let's see, whenever we attack, let's make some noise. Let's see, get actor location. You will have to turn on your noise emitter by checking auto activate, and then still doesn't quite work yet. All right, I found the bug. The reason why my player isn't emitting noise is because when the player attacks, they're not actually calling the attack function. If I go out to the event graph, you'll notice that I'm actually completely ignoring that function and just calling the attack function inside of the weapon component. So I'm going to get rid of that and actually call the built-in attack function that we wrote for our player. And then in there, we are doing our weapon components attack, and then we're making noise. So if things go correctly, when I hit play, if I click, my player will make noise, and the enemy will turn around because they sense me. So just like that, we've created an AI system with just really simple behavior, the ability to equip different weapons and attack. And then we also have a kind of a stealth system started because we can now rely on senses, sight and sound, for whether or not that orc senses us. So from here, this is just a really simple, low-level example. You guys can take this and build on it and turn it into something really great. So if you have any questions, of course, hit me up over email or I'll see you in class this week. So just write down your questions and let me know. All right, see ya.